So lesson number 4 is on the average rate of change of a function. So the average rate of change, there's a whole big definition here. It says the average rate of change of a function f is the slope between the two endpoints on the interval. So in other words, it's f of b minus f of a all over b minus a. So the f of b minus f of a, that's just our change in y. And our b minus a, that's going to be our change in x's. Okay, so see how it's just the slope. Yeah. Okay. Right now?
Yeah.
Okay. So for this one, if I'm going to do f of b minus f of a all over b minus a, I'll get your homework, hang on. It's going to be f of 1 minus f of negative 2 all over 1 minus a negative 2. And it doesn't matter what order, you could have done the negative 2 first and the 1 second, as long as you're consistent on the top and the bottom. Yeah.
Thank you.
All right, so we need to find each of those things. So if I'm finding f of 1, that's saying the y value where the x value is 1. So what point is that? That is 1 comma what? Negative 1, right? So f of 1 is negative 1. And f of negative 2, it looks like 1, right? So we have negative 1 minus 1 over 1 minus a negative 2 is 1 plus 2. So we get negative 2 over 3. That's our average rate of change. So if you want to abbreviate average rate of change, you can write ARC if you want to. It doesn't matter. There is no abbreviation. You could even write M. I would be okay with that for slope. So basically what that means is this curve doesn't have any endpoints, but on this particular interval, if I connected the endpoints of that interval, the slope is negative 2/3. And you can count it. If you count down, it's down 2, right 3, right? That's the slope, rise over run. So it's good. So the next one doesn't actually have a graph. You're just supposed to find each thing. So we're going to find f of 0 and f of negative 2. So if you want to find those first, you can. Like some people like to do that. So f of 0 is going to be 0 squared minus 5, which is negative 5. And f of negative 2 is going to be negative 2 squared minus 5, which is 4 minus 5, so negative 1. So when you find f of b minus f of a all over b minus a, f of 0 was the negative 5, f of negative 2 was negative 1, all over 0 minus a negative 2 is going to be positive 2. So we get negative 5 plus 1 is negative 4 over 2, which is negative 2. Okay, so all we're doing is the slope. Easy enough? Okay, the thing that's going to get weird is we're not always talking about the slope between two numbers. Maybe I want the slope between 2 and 2 plus h. And this is something that you will do all of the time in calculus. Okay, because we do something called a derivative in calculus, which is just the slope. But it's basically the slope at a single point. And the way that we do that is we have like between 2, let's say we have a curve here, and then we say, okay, a little bit more. We're going to add h, and h is going to be tiny. And then we're going to find the slope between those two things. And then we make h get smaller and smaller and smaller. So we're like, okay, h is 1, and then h is 0.1, 0.01, 0.001, until it becomes just a single point. So it's kind of weird. The average rate of change. All right, so for this one, we're going to do f of 2 plus h minus f of 2 all over 2 plus h minus 2. So do you guys see we have our a and our b? Okay, so when I ask something like f of 2 plus h, it's not as easy as the numbers. If I was asking like f of 5, you know you're going to replace all of the x values with 5, right? So when I say f of 2 plus h, what I want you to do is replace all of your x values with parentheses 2 plus h, okay? So we're going to go in here and we're going to replace our x value with 2 plus h. So we have 3 2 plus h squared. So that is going to be just the f of 2 plus h. Then we're going to have minus. Now we want f of 2. Well, that's going to be 3 times 2 squared. That is the second part of it. And it's all over 2 plus h minus 2. Well, what is 2 plus h minus 2? Just h, right? It's from the function. So we're saying plug Instead of x, you're going to replace with 2 plus h, so you have 3, and it was originally 3x squared, so it's 3, 2 plus h squared. All right, so we need to find what 3, 2 plus h squared is. Okay, so you can do it off to the side if you need to. So basically, if you have a 2 plus h times itself, you're going to end up getting 4 plus 4h plus h squared, right? So we have 3 times that. So basically, we're going to have the 3 out front. So we're going to end up getting 12 plus 12h plus 3h squared. That's what the part that was in blue. So maybe I'll keep it in blue so you can see it. That's what it is when it's simplified. Does everybody understand that? So I FOILed out the 2 plus h, and then I multiplied the 3 in. Yeah, Catherine?
Why is it 12?
Because I'm multiplying that 3 in as well.
But why is it 12 plus 12h?
It was 2 plus h squared. So when you FOIL, you get 4, 2h, 2h. You got it?
Plus h as the second.
Like 2 minus h?
No, I did 2 and then 2 plus h.
Oh, I see. Yeah, so 2 plus h times both. Or 2 plus h times itself. All right, and then we have minus. So what do we get when we do 3 times 2 squared? What number is that? 12. All right, all over h. So we continue to simplify. So 12 and then minus 12 goes away. All right, so we end up getting 12h plus 3h squared all over h. Which reduces, yeah, Emily?
Is this usually like the best fit line?
It's not the best fit line, no.
Like on Excel, you know?
No. There's a lot of math with that too, but it's not the same. All right, so we're going to pull the h out. So when we pull an h out, we have 12 plus 3h all over h. So we reduce out, the h and h reduce out, we get 12 plus 3h. So that's our answer.
Or are we supposed to do
I would just leave it as 12 plus 3h, yeah. All right, so basically you don't have to do that pull the h out thing. You could just do kind of the little heart thing we talked about, like bring the h into both pieces. You could do that as well. So like h goes into this one and h goes into this one, and kind of skip that last step. Okay, so it's a lot of steps. So you have to be very, very careful as you're writing it out. So we're going to do several examples of this. You'll understand it. All right, so it says linear functions have constant rates of change. Linear functions, their slope, their average rate of change, is always the same, right? It's always the m. So this is every single example I do for number 1, it's going to be the same answer. It's going to be 2. I can tell that it's going to be 2. So it says show that the rate of change for f of x equals 2x plus 3 is always 2. So we're going to try A, B, and C. So if we have numbers, it's easy. It's going to be f of 4 minus f of 0 all over 4 minus 0. So f of 4 is 2 times 4 minus 3. And f of 0 is 2 times 0 minus 3 all over 4. So we're just plugging in 4 and plugging in 0, and then writing brackets around each one. So the first bracket is going to be 8 minus 3, which is 5. The second bracket is going to be 0 minus 3, which is negative 3. So we end up getting 5 plus 3, which is 8 over 4, so we do end up getting 2. So that's exactly what we thought it was going to be, because the slope, right, is 2. I know, spoiler alert. So this next one's going to be the same thing. So if I do f of 50 minus f of 3 all over 50 minus 3, I should get 2. So f of 50, what do you guys get when you plug in 50 into the function? 97. What do you get when you plug in 3? All over 47. So we get 94 over 47, which, surprise, surprise, is 2. So we like the linear ones. It's like, oh, I know what I'm going to get. The other ones that are going to be harder. All right, so we're going to do it one more time. So we have x equals a and x equals a plus h. So we don't have numbers this time. We have everything as a variable. So we're going to find f of a plus h minus f of a all over a plus h minus a. All right, that's our f of b minus f of a all over b minus a. So our function was f of x equals 2x minus 3, right? Was it a minus 3? Yeah, 2x minus 3. So when we plug in a plus h to the function, we have 2 times a plus h minus 3. That's the first bit. That's f of a plus h. Minus f of a is going to be 2 times a minus 3. And it's all over a plus h minus a, which becomes h. And we continue to simplify. So we have 2a plus 2h minus 3. And then we have minus 2a minus 3 all over h. So we get 2a plus 2h minus 3 minus 2a plus 3 all over h. And when you have these problems that have h in them, a lot of things are usually going to cancel. Okay, so let's look and see if anything reduces out. Yeah, do you guys see how the 2a and the negative 2a go away? And we see the negative 3 and the 3. So we end up with 2h over h, which is 2. Surprise, surprise, right? I know, you're shocked. All right, so it's not really, we don't do this for linear functions. We know what their slope is regardless. Okay, the whole reason that we do this is because in calculus we're going to have these curves, and we're going to want to find the equation of a tangent line to the curve. We want to know what that slope is at a particular point. Okay, so it's kind of leading you to these calculus concepts. Okay, so this one says find the average rate of change, so the slope, between x equals 3 and x equals 3 plus h for this function. So f of x equals 2x squared minus x. So we're going to find f of 3 plus h minus f of 3 all over 3 plus h minus 3. And it's going to get messy. And we're going to be positive. We can do this. Trust me. So it's the same idea. We want to find what f of 3 plus h is. So what we're doing is we're replacing those x values with 3 plus h. So we're going to have 2 parentheses 3 plus h squared minus parentheses 3 plus h. That's f of 3 plus h. And we're going to do minus f of 3. Well, f of 3 is going to be 2 times 3 squared minus 3. And we do all over 3 plus h minus 3, so all over h. So it gets to be a lot if you're writing out every single step with the whole quotient. We call this the difference quotient, with this whole quotient. So sometimes, like I did before, I'm going to go ahead and find what 3 plus h times itself is. So I'm going to FOIL it out. If you can do this in your head, it's fine. So we get 9 plus 6h plus h squared when we FOIL it out. But then we're going to have times a 2, right? So when we multiply by 2, we're going to end up getting 18 plus 12h plus 2h squared. Then we have minus 3 plus h in parentheses, so we're going to have minus 3 minus h. That is all in the first bracket. Then we have minus, what does that second bracket become? 15, good. All over h. Okay, we're almost there. That was the hardest part of the simplification. So now we just need to continue to combine our terms and reduce. So we have 18 minus 3, which is 15, 12h minus h, which is plus 11h, plus 2h squared, minus that 15 from before, all over h. So do you see the 15s go away? So what's our answer when we divide by h? 11 plus 2h, that's it. So we just bring the h into both pieces. Can you do it? Okay, breathe a little bit. It's all right, you can do it. So we're going to try a couple of these, so how about you guys try the next one? Okay, so quite a few people in the last class did not think they had the right answer on the next one, and they did. They got it. So it's saying find the average rate of change between a and a plus h. So go ahead and try it. You should have a and h in your answer. So your final answer will have both a and h. All right, so same idea for this one. So we're going to do f of a plus h minus f of a all over a plus h minus a. So when we do f of a plus h, it's a pretty long one. So you're going to have a plus h squared minus 3 times a plus h plus 1 minus f of a is going to be a squared minus 3a plus 1. All over a plus h minus a gives you h. So you FOIL out the a plus h. So when you do a plus h times itself, you should have a squared plus 2ah plus h squared minus, so now we distribute this negative 3. So we're going to have minus 3a minus 3h plus 1. And then we'll distribute the second negative. We'll have minus a squared plus 3a minus 1. Longest numerator ever, right? So we look for things that reduce out. So we know that a squared and negative a squared go away. Negative 3a and positive 3a. 1 and negative 1. Anything else? No. So if you did it correctly, every time you do that, you should only have things that have h, because this h on the denominator should go away. So when we divide by h, so it goes into all three things, you end up getting 2a plus h minus 3. And that's your answer. Okay, so a lot of you guys got it? Good. So number 4 says a construction worker drops a bolt while working on a high-rise building 320 meters above the ground. After t seconds, the bolt has fallen a distance of d meters, where d is 320 minus 5t squared. That's very, it hurts me to see 5t squared. It should be negative 4.9t squared. It should include the gravity constant, but it does not. The gravity constant is 9.8 meters per second squared. You guys know that. So half of that, whatever. Anyway, so it's a little bit off. So it says, what is the average rate of change? In other words, the average velocity of the bolt between 2 and 5 seconds. Okay, so don't be scared just because there are words in the problem. All we're going to do is like f of b minus f of a, but we don't have f for our function. Our function is d. So it's going to be d of 5 minus d of 2 all over 5 minus 2. And when we do this, the d was in meters. And the 5 and the 2 were in seconds. Okay? So when we find this average rate of change, what it really is the average velocity. We end up getting something in meters per second. Okay, that's why I said i.e. the average velocity. Okay, so we find each of these things. So we find d of 5, so we do 320 minus 5 times 5 squared minus d of 2 is 320 minus 5 times 2 squared all over 3. Okay, so the first one, 320 minus 125, so 195 minus 320 minus 20, so 300 all over 3. So we get negative 105 over 3, which is negative 35. So I would put units, it's in meters per second. Does it make sense that it's negative? Those of you that are in physics? Yeah. If a velocity is negative, it means it's either moving backwards, like if it was on a flat, like a car would be negative if it's going backwards, or it's falling down. And in this case, we have something that's falling down. So it makes sense that it's negative. If you talk about speed ever, speed is never negative. Speed is always the absolute value of your answer. All right, so let me pass out your homework.